Okay, fine. So let's continue. Let me share my screen. So yesterday we skipped at this point. So this is what is the scenario. The memory reference instructions and register reference instructions, what we have studied, as per there are 19 instructions we have designed. 19 instructions we understood that what these instructions will perform. Still don't worry, we'll be understanding them in details, few of the instructions. Okay, so the thing is, in this case, register memory reference 7, register reference 12, so 19. Now as what we had seen in register reference instruction 0111, that is 7 is fixed. So 7 in the code is fixed for the register reference instruction. Okay, but regarding memory reference instruction, if you check out, then in that case, if this is a memory sorry, yes, if this is a memory reference instruction, then in that case the opcode is changing. But in case of register reference, the opcode part is remaining fixed. That is 7. Over here, see, you can see the numbers are changing: 0 to 6, then 8 to E. 7 and F not included. Now I have justified why 7 is excluded in this list, because 7 was used over here. Okay, so this is our register reference. Now the last type of instruction which we need to understand is input output instruction. If you can check out the format of input output instruction, it is similar to register reference, but only the difference lies is this number of bits. That is 1 1 1 1. They are fixed. In case of register reference, it was 0 1 1 1, whereas in case of input output 1 1 1 1, we have fixed it. What is hexadecimal equivalent of 1 1 1 1?
F.
F. So now what we have done, we have made F fixed for IO. Rest these bits will be changing. 0 to 11 will be changing. So F will be fixed. Again, now you might be clear why I have skipped 7 and F in our memory reference. So this was the only reason why I have skipped 7 and F, because 7 was for register reference and F is for IO. Clear? Now IO. Now if I say IO means input output. Input output instructions, that means the operations which are carried out with input output devices, those instructions will be considered as input output instructions. So can you tell which are they? Okay, starting with the first. Who will tell me the code for this? See, there is a change in the code, change in the bit. If you can see instruction code 0, I made it 1. Can I say it is F800? Exactly. Now I am assigning the code F800 to the instruction INP, which stands for input character to AC. Means whatever input device is there, input the character from that device and store it into the accumulator. That's it. Very simple. Now still this part, inputting a character to AC, is divided into two parts, which I'll discuss it later on. It will not go directly to the accumulator register. That is another part which we'll discuss in detail later on. Next instruction code which we can have is this. Can I say it to be F400? And the instruction name I am giving is out, which stands for output character from AC. Means I am having one output device, consider it to be a monitor or printer, any device, any output device you take it. I want to send the output, send the character from processor to that device. Then in that case, output instruction will be used, wherein this output instruction will send the data from accumulator register only, no other registers, only AC, to your output device. And again, it is divided into two parts, like input what I said, which again we'll be discussing at the time of discussing input output operations. The next instruction, which you will for sure not understand, and again I'm not going to make you understand at this point, and that is code for it is F200. Instruction name I am giving is SKI. SKI stands for skip on input flag. Now, skip on input flag. Let me slightly elaborate it. Skip on input flag means skip next instruction on input flag. Now the question will surely arise, sir, what is input flag? That's why I said we will not understand this at this time. When we will be discussing input-output operations in detail, at that time you will be clear about this point. So what is input flag? I'll discuss it at that part. Just right now, just remember the instruction that there is an instruction named as SKI whose code is F200. Similarly, we are having the next instruction to be F100. And I am giving the name to be SKO. So similarly, can anybody predict what is SKO? Yes, can anyone predict?
Skip output flag.
Exactly, skip on output flag. It's absolutely correct. Everything is predictable. Skip on output flag means skip the next instruction on output flag. Again, question will come, sir, what is output flag? Don't worry, we'll discuss it. Now the next instruction, again, the next instruction you are not going to understand, but the code you can understand. It is F080. And I am giving the name to be ION, which stands for, it's not ION, no, it's ION. ION stands for interrupt on. Again, question will arise, sir, what is interrupt? Without interrupt, computer cannot work. Just remember it. Without interrupt, computer cannot work. Then how these interrupts are going to work? Don't worry, we'll be discussing in the lectures. Okay, next comes out to be F040. And the code is assigned to IOF, which stands for interrupt off. Okay, so interrupt on, interrupt off. How many instructions till now? 6 input-output instructions. There are only 6 input-output instructions as per our design. No more instructions are there. If you take off talk about 8085 microprocessor, Intel 8085 microprocessor, then in that case it is having around 75 instructions, if I am not wrong. So right now, how many instructions we have studied? 7 register memory reference, 12 register reference, and 6 IO. So as per our design, we have designed 26 total instructions for the processor. Is it fine? All of you? Everyone, please.
Yes, sir.
Yes, sir.
So now what your role is, or what you have to do is, you have to mug up all these instructions with their description. That means you need to remember these tables. Code, mnemonic. This is mnemonic, as I had discussed it earlier. Code, instruction code, then mnemonic, and the description. This is what you need to mug it up. Because in exam it can be asked, explain the following instructions. So you need to explain the instruction. Again, these instructions I will be coming into the detail of working of it, don't worry. Okay, fine. So let's move further. There is one very small topic named as instruction set completeness. Means if I am designing the instruction set, then what should be bare minimum included in that instruction set? So the first and foremost thing what they are saying is that instruction set should consist of arithmetic, logic, and shift instructions. Secondly, they are saying that there should be instructions available for transferring data to and from memory and processor registers. That is what I have discussed, LDA and STA. Then program control instructions should also be there that check status conditions like what I had mentioned: SPA, SNA, SZA, SZE. They are program controls. Skip on next, skip on if AC is positive, skip next instruction if AC is negative. So they are program control, because we are controlling the execution of the program. That's why. And lastly, it should consist of input output instructions. So if I want to say my instruction set is complete or not, then these four operations, these four tasks, if all the instructions are able to complete all these four tasks, then we can say that instruction set is complete. Is it clear? So it can be asked, what are the necessary conditions for instruction set completeness? So you should mention that the below category instructions should be present into the instruction set. That the first is arithmetic logic shift, second is the data transfer from memory to the processor registers, and program control third one, and fourth one is input and output. Chalo, is it fine everyone? If you are clear with this, then I want to today move on to the most important topic of this chapter. That is what we could term it to be control unit. See, now you are on the verge of controlling your operations. Till now you have studied what operations are there. Now you will be studying how we can control these operations. Okay. Hello, am I audible?
Yes, sir.
Yes, sir, you are audible.
Okay, because I didn't got response from you people. Okay, fine. Just tell me, what is this in front of you?
Instruction register.
Instruction register.
What is the use of instruction register?
It give the instruction to the which operation we have to perform.
Exactly, very good. Then anything else? Means what this instruction register will store?
Instruction register store the instruction.
Absolutely correct. Instruction register is present into your computer processor, which stores the instruction fetched from the memory. Please remember this statement. Instruction register stores the instruction which is fetched from the memory for execution. Is it clear?
Yes, sir.
Yes.
इंस्ट्रक्शन रजिस्टर का काम ये है कि वो पहले मेमोरी में से जो भी इंस्ट्रक्शन एग्जीक्यूट करनी है उसको फेच करेगा और इंस्ट्रक्शन रजिस्टर में इंस्ट्रक्शन स्टोर होगी, और जो भी इंस्ट्रक्शन रजिस्टर में है वो प्रोसेसर उसको एग्जीक्यूट करेगा. Is it clear now? Very simple.
Yes.
So if I want to execute add 457, my program, there are 10 instructions in my program. Sir, you are talking of program, but you have never shown the program, simple program. Don't worry, I'll show you that. There are 10 instructions in a program, and out of those 10 instructions, say for example the third instruction is on the execution, it will start the execution from first, like what we do it into a void main. Means in C programming we start the execution from void main, then the first statement will be executed, then seconds, and sequentially. Same way over here the same thing will occur. So in that case the first instruction comes into the picture, which is stored in memory. It will be fetched and stored in the instruction register. Okay. Now, how computer will know that which instruction is to be executed? So that is the main task to be carried out. Are you getting my point? All of you? So
Yes,
now कंप्यूटर को कैसे पता चलेगा कि कौन सी इंस्ट्रक्शन मुझे एग्जीक्यूट करनी है? कैसे पता चलेगा? अकॉर्डिंगली क्या कमांड देने होंगे मुझे? That is what we need to understand. What commands are to be provided to the other units so that my instruction gets executed. Are you getting my point? So first and foremost thing comes into the picture is instruction register. Now, say for example, before moving to this, you just tell me, say for example, you people are given instruction that from Monday onwards, college is starting. Say for example, what you will do, how you will interpret it, that on Monday college is starting. Say for example, what will be the time of the college? The time of the college will be second shift, wherein you need to come to the college at 9 o'clock. Your first lecture will start, and the first lecture is of COA. How did you came to know that this is COA lecture or OS lecture? Based on the timetable which you got. The same thing is over here. Control unit will first of all check out what instruction is there into the processor, and it will decode that instruction. It will decode that instruction, which is the instruction in the instruction register. Decode. I am using the word decode. Okay. Now let's move further. These are the control logic gates available with us. We don't know what is there. It is a block in that. There is one unit I am using it to be 4-bit sequence counter. Are you aware about sequence counter? Hello? Have you heard the term sequence counter?
Yes, sir.
Yes.
What is the work of
Yes.
sequence counter? 4-bit sequence counter. So it will start from 0000. Then on next it will be 0001. Then next 0010. Then next 0011. Then next 0100. So it will go till 1111. Then again reset. Yes or no?
Yes.
So 4-bit sequence counter I am using. So based on this 4-bit sequence counter, can I say I can get 16 possible combinations? Sir, how 16 possible combinations?
Yes.
How? I will be multiplexing them using decoder. See, 16 possible combinations I can get. I am using 4x16 decoder. 4 inputs, 16 outputs. Am I correct?
Yes,
Yes or
sir.
no?
Yes, sir.
4-bit will be generated in sequence correspondingly T0, T1, T2, T3, T4, T5 till T15. I'll be getting one by one.
Yes.
Can I say I have created a clock using this? Tick tock, T0, T1, T2, T3, T4, T5. Sequentially, I'll be getting the ticks of the clock.
Yes.
So my clock of the processor will work from T0 to T15. जैसे हमारे clock में seconds का जो count आता है, it starts from 0, it goes till 59, 60, and again it resets to 0. The same way over here, the processor clock what I am giving, it will start from T0 to T15. Is it clear? All of you?
Yes, sir.
So what I am doing is I have used one 4-bit sequence counter. That is what I am telling it to be SC. That is giving its output to 4x16 decoder, which generates a pattern of T0 to T15, making them 1, rest all 0. If T0 is 1, then rest all will be 0. If T1 is 1, then rest all will be 0. If T2 is 1, then rest all will be 0. Okay? Should I move further?
Yes, sir.
Now comes the picture. 0 to 11 bits are directly given to control logic gates of control unit. But main thing is which instruction is there that needs to be decoded, because we are having 25 instructions as per our instruction set. Yes or no? So processor needs to first of all decide which type of instruction it is: memory reference, register reference, or IO. And for deciding them, how will you be able to bifurcate them? Can anybody tell me? How can you differentiate that this is memory reference, this is register reference, or this is IO? All of you, how can you bifurcate?
Sir, can you repeat one more?
My question is, okay, my question is, how can you bifurcate that this instruction is IO instruction? Say, for example, I write ION. This is instruction ION.
Okay.
ION belongs to input output. Repeating my question, sorry, you are getting confused, I am understanding. Say, for example, ION instruction comes for the execution into the processor. How computer will understand which instruction it is? So first and foremost, from ION, it needs to decide whether it is input output or memory or register reference. Yes or no? Yes or no?
Yes.
तो
Yes.
अभी my question is, how processor will decode कि भाई ये कौन से type का instruction है?
Using I bit.
Using I bit only? No, no. अगर रजिस्टर रेफरेंस, सपोज इफ इट इज एन इनपुट आउटपुट इंस्ट्रक्शन, तो हमने क्या देखा एज पर फॉर्मेट, क्या कॉमन रहता है? अगर इनपुट आउटपुट इंस्ट्रक्शन है तो उसमें कॉमन क्या चीज है? सब इंस्ट्रक्शन में, ये सब इंस्ट्रक्शन आपके पास है, उसमें कॉमन क्या है?
F.
F. Did you get this? F is
Yes, sir.
common for all input output register in input output instructions. Similarly, what is common in register reference instruction?
7.
7.
Means opcode.
Opcode, exactly. Now what if it is 7, then we can say register reference.
Yes.
If it is F, we can say input output instruction. All of you.
Yes.
What if it will be 0 to
6.
6 and 8 to E?
Memory.
तो अभी 7 नहीं है, F नहीं है, तो क्या रह गया अभी?
Memory reference.
Did you get this? So computer will think in that sense only कि भाई यहाँ पे 7 नहीं आया, F नहीं आया, तो क्या है? तो 0 से लेके F के बीच में 7 और F स्किप कर दे, तो बाकी जो भी है तो इट विल बी नथिंग बट मेमोरी रेफरेंस. Is it fine, everyone?
Yes.
So coming to that part only, I am decoding these 3 bits. These 3 bits, 12, 13, 14. Decoding means 3 to 8 decoder. So that decoded line's output I am giving to my control logic gate, and 15th bit which is there, that is I bit for us, is stored in I and again given to the logic gates. Now the question is, this is nothing but control unit of a basic computer. Sir, अभी इसमें मैं कुछ समझ में नहीं आया. Don't worry. Say for example, this is your instruction. Instruction will be always in binary, no? Yes or no?
Yes.
Yes.
So can you people tell me which instruction it is? I'm waiting for the reply. Huh?
And
Huh? And
Yes.
No. How you will be deciding the instructions? First of all, convert this binary to hexadecimal code. What is the hexadecimal code for this binary numbers in front of you? Which are the hexadecimal code for this binary number?
1 8.
1. आज मुझे क्यों ऐसा लग रहा है कि आप लोगों को कुछ या तो समझ में नहीं आ रहा है या तो सब ऊपर से जा रहा है या फिर इंटरेस्ट थोड़ा आज कम है.
Sir, 35E
35E, how?
combination of the binary.
No. How you will be converting binary to hexadecimal?
Combination of 4 bit.
1 4 5 6.
Combination of 4 bits means you will be making group of 4
No.
bits. So what
No,
will be the
four-
group
four,
of
five,
these 4?
six.
1.
0.
4 5 6.
Repeating it again.
1
This is 1,
4
4, 5,
5
and
6.
6. Yes or no?
7, sorry.
7. 1, 4, 5, 7. Yes or no?
Yes.
1. Just a minute. It is 1, 4, 5, 7. Yes or no? Now tell me, which is this instruction?
Memory reference.
Memory reference, because it is not 7, it is not F, so it is memory reference. Did you get this now?
Yes.
All of you?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
Okay. One more thing.
Yes,
This
sir.
is what we are interpreting. A computer is not going to interpret in this way. Don't worry. We came to know that this is memory reference because it is 1. And again, in that case, whether it is direct instruction or indirect instruction?
Direct.
Direct. Okay, because it was 1. If it would be indirect, then it would be starting from 8. Yes or no?
Yes.
Again, you tell me from this that which instruction it is out of our 7. 1 है तो 1 किसका कोड है हमारे पास?
End. Add.
Add, exactly. See, we were having the code. If you remember. See, 1 किसका कोड है हमारे पास? It is for add. Are you getting my point?
Yes.
So now control unit will give accordingly the commands that you are supposed to perform add operation. So let me come back again. Now see, the instruction is what we are having, this instruction. What computer will do? It will decode these 3 lines 0, 0, 1. Which signal will be generated from this decoder? 0, 0, 1 means
Add.
add, but out of this decoder, which line will be 1?
1.
1. So it will be 0, 0, 1 given as an input and you'd be getting D1. Yes or no?
Yes, sir.
So when there would be an add when there will be an add instruction under execution, this D1 line will consist the data 1, rest all line will be 0. Did you get this now?
Yes, sir.
So now you have to tell me if my instruction comes out to be 0, just a minute. If the instruction is 0, 0, 0, 0, 1, 0, 1, 1, 1, 1, 0, 1, 0, 0, 0, 0. What is this instruction?
End.
End. First of all, how did you make out end?
0.
It is memory reference. Sir.
all zeros. So memory reference, all these 4 bits 0. So hexadecimal value is 0. So it is a memory reference. And again in memory reference, which type of instruction?
And
End, because all 4 bits are as 0. So it is end. But how computer will decide that 0, 0, 0? That means over here decoder inputs will be 0, 0, 0. Which line will be enabled?
0.
D0 line will be enabled. That means processor will come to know that at when decoder output is D0, that means on D0 line it is 1. That means it is going to be AND instruction. Did you get the working of this?
Yes.
All of you?
Yes.
Okay, let me give you one more example. What if I give the instruction to be just a minute. 1 1 1 1 1 0 0 0 0 0 0 0 0 0 0 0. Now can you tell me
F.
what is the total code, complete code? F 8 0 0. Yes or no?
0. Yes.
So F comes into the picture. That means all these three bits 1 which are to be decoded. So over here it will be 1, over here it will be 1, and over here it will be 1. Yes or no?
Yes.
What will be the output of this decoder?
clear
7
SC.
line will be selected.
Line number
7.
7. So D7 will be the output. Is it?
Yes.
Okay. Again changing another. So just remember, when it will be IO instruction, D7 line will be enabled. Yes or no?
Yes.
But again, now my question comes is, again my question comes in picture is, I am giving the instruction 0 1 1 1 1 0 0 0 0 0 0 0 0 0 0 0. Which is this instruction? What is the code first of all?
7800.
7800. So what will be the output of the decoder?
6.
Huh? What will be the output of the decoder? यहाँ पे भी 1 होगा, यहाँ पे भी 1 होगा, यहाँ पे भी 1 होगा.
7.
7th
7.
line.
तो रजिस्टर रेफरेंस में भी D7 में से ही आउटपुट आया ना?
Yes. और उसमें IT सिलेक्ट
सॉरी
F वाले में
I 1 था.
हाँ, exactly. So in case of register reference, I bit will be 0, and in case of input output, I bit will be 1. Is it clear, everyone?
Yes.
Should I move further?
Yes.
All of you? So this is what is your control unit of a basic computer. Don't worry, we are going. This is now timing you have decided. Huh? Actually, you have decided the timings now. Okay. Now, see, these are the theory part. That 2 decoders are there, 1 sequence counter is there, control of the gates will be used, instruction will be placed into the memory with everything I have discussed. Okay, 12 to 14 bits will be your opcode, which will be decoded, and correspondingly we will be getting decoded output D0 to D7 and so on. So all these stories I had mentioned. But now my main concern over here is understand this line. This is what I'm going to teach you now. D3 T4 SC equals to 0. What is the meaning of this line? We have studied, just first of all tell me, what is the meaning of this statement? We have studied register transfer language. What can you tell me? What is the meaning of this line? हमने ऐसा कुछ एग्जाम्पल तो पढ़ा ही है. P colon R2 arrow R1. Yes or no? Yes or no?
Yes.
तो इसका मीनिंग क्या था? What was the meaning of this statement? अभी फर्स्ट सेकंड लेक्चर का भूल गए आप लोग. क्या करूं मैं?
सर ऐसे मतलब
नहीं 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 नहीं, ये भूल
काउंटर
जाओ. नहीं, इसको अभी भूल जाओ. इसका मतलब क्या हुआ? P colon R2 arrow R1.
R1 is derived from R2.
हाँ 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 हाँ. चैप्टर नंबर 1 सेकंड लेक्चर. अरे बोलो, आई एम वेटिंग.
When P is 1, then transfer the content of R1 to R2.
परफेक्टली वेल. तो अभी इसको इंटरप्रेट करो. अभी इसको इंटरप्रेट करो.
When D3 and D4 is 0.
जीरो कैसे? अभी यहाँ पे P का क्या मीनिंग लिया है? Repeating the meaning of this statement. When the value of P will be 1, at that time the content of R1 will be transferred to R2. So same way, when D3 will be 1 and T4 will be 1, at that time sequence counter SC is assigned the value 0. Did you got this statement now?
Yes.
ये दोनों वैल्यू 1 होनी चाहिए. D3 की भी 1 और T4 की भी 1. तब we can say that the value 0 is assigned to sequence counter. Is it clear?
Yes.
ये एक एग्जांपल मैंने आपको दिया. तो अभी ये स्टेटमेंट को मैं कैसे इंटरप्रेट करूंगा? When D3 is 1 and both values should be 1. When D3 is 1 and T4 is 1, at that time I want to make sequence counter value to be 0. So similarly I can say any statement. Again, this is what we are mentioning the time कि भाई D3 T4 जब 1 होगा तब सीक्वेंस काउंटर में वैल्यू हमें 0 असाइन करनी है. Is it clear? All of you?
Yes, sir.
Yes, sir.
Should I move further?
Yes.
Now let us see this part diagrammatically with respect to our clock cycle. Now अभी D3 और T4 वैल्यू 1 कब होगी? यहाँ पे देखिए. अरे सॉरी, D3 T4. D3 कहां से आएगा? ये डिकोड होके आएगा. ये पार्ट यहां से डिकोड होके D3. सो ये D3 1 होगा और T4 1 होगा. T0 T1 T2 T3 T4 ये दोनों 1 होंगे. तब हमें क्या करना है? सीक्वेंस काउंटर SC को 0 करना है. मतलब ये क्लियर लाइन सिग्नल देना है. कैन आई से लाइक दिस?
Yes.
This is one operation, example operation I had taken. Let's see with respect to waveforms. This operation with respect to waveforms. The clock is going, see, this is the clock going T0, T1, T2, T3, T4, T5 till T16. This will continue till T16 because our sequence counter will generate, T15. Our sequence counter will start from T0 till T15. So total 16 ticks it will be generating. So this is T0. See, T0 started. Once T0 will be completed, T1 will start. Once T1 will be completed, T2 will start. Once T2 will be completed, T3 will start. Can I say like this? All of you? Then similarly T4. When T3 will be completed, T4 will start. So this is how clock works, no? Yes or no? Can I say first second, second second, third second, fourth second, fifth second, and so on? But what I have stated is when D3, T4, so my D3, see my D3 is made 1 at this point of time. But at that time T4 was 0 only. So at that time I am not supposed to do anything. A clear signal for AC is 0. You can make out. It is 0. It is 0. But when T4 got 1, see, when T4 became 1, sorry. So see this, when T4 became 1 and D3 was 1, at that time clear signal became 1. Otherwise it was not. See this, at this time, if you can make out, because T4 is 1 and D3 is also 1 at this time. So at that time, clear signal became 1. Is it fine? All of you? सर अभी इसका यूजेज कहाँ पे आएगा? कहीं पे नहीं आएगा. दिस इज द टाइमिंग डायग्राम. देखो यहाँ पे T4, when T4 was 0, but still D3 was 1. Both were not 1. Either of these was 1. So at that time I am not supposed to give clear signal. But when both became 1, I am supposed to give the clear signal. Is it clear all? So this is what is timing cycle for D3, T4, SC equals to 0. Now similarly you can have many timing cycles for different operation. This is a simple operation I had taken. Okay. So today we stop here at this moment. With this, our control unit of a computer is over. But now this was the design. Now from next lecture onwards, we will be discussing how the control unit will handle the instructions individually. Okay. So today we stop here. Roll number 109. Roll number 109. Absent. 180. 180. 180. Absent. 222.
Present, sir.
41.
Present, sir.
68.
Present, sir.
69.
Present, sir.
70.
Present, sir.
71.
Yes, sir.
73.
Yes, sir.
74.
Yes, sir.
75.
Yes, sir.
76.
Present, sir.
77. 77. 77. Absent. 78.
Present, sir.
79. 79. Absent. 80.
Present, sir.
81.
Yes, sir.
82.
Present, sir.
83.
Present, sir.
84.
Present, sir.
85.
Present, sir.
86.
Present, sir.
87.
Yes, sir.
88. 88. Absent. 89.
Present, sir.
90.
Present, sir.
91.
Yes, sir.
92.
Yes, sir.
93. 93.
Yes, sir.
Absent. 93.
Yes, sir. Yes, sir.
95.
Yes, sir.
Present, sir.
99. 99.
Yes, sir.
100.
Yes, sir.
1. 101. 101.
Yes, sir.
102.
Yes, sir. Present.
105.
Yes, sir. Present.
106.
Yes, sir.
108.
Present, sir.
109. 109. 109. Absent. 111.
Present, sir.
112.
Sir, 111 present.
111 present. 112. 112. Absent. 130.
Present, sir.
133.
Present, sir.
150. 155. D2D 1.
Present,
2.
sir.
D2D 2. Absent. 3.
Present, sir.
4. Absent. 5.
Present.
6.
Present, sir.
7.
7 present.
6.
Present, sir. 6.
7. 8.
Present. Present.
9.
Present, sir.
10.
Present, sir.
11.
Present, sir.
12. 12. 12 absent. 13. Absent. 14. 14. Absent. 15.
Yes, sir.
16.
Present, sir.
19. 17.
Yes, sir.
18. 18.
Present, sir.
19. 19. 19 absent. 20.
Present, sir.
20.
Present,
21.
sir.
21.
21 present. 21
22.
present.
22. 24.
Present, sir.
25.
Present, sir.
26. Sorry. 41.
Present, sir.
42. 42. 42 absent. 44. 44 absent. 44 present. 44 present. Who is 44?
Sir.
Cable, are you 44? Okay. 45. 45 absent. 46.
Present, sir.
47.
Present, sir.
48.
Present, sir.
49. Absent. 50. 49 present, sorry. 50.
Yes, sir.
50. Anyone left out?
Sir, 02 present.
02. D2D, ne? Okay. Then,
Hello, sir.
yes, Renik.
I'm